Hi guys and welcome after the break. I hope your shutdowns went well, so now we can get back to our regular schedule and I can go back to making the regular videos. So I'm going to continue today the latest topic that I started, which is the data registers and position registers. Today is the part 2 and I'm going to cover the position registers today. So let's get ready for that. Alright, so we've talked a little bit about the data registers in the previous video. If you haven't seen it, I will link it up top somewhere here. So please check it out because there are some basic cover over there, and today we're going to go a little bit deep more inside the details of the data registers. So what are the data registers for, guys? Like I said before, they are used to store numbers, either a real number or an integer, depending what you need. And what are the operations allowed on the registers? So we can copy registers, we can do mathematic operations on it, like sum, subtract, multiply, divide, and there are we can use also them in a mixed logic. And there are two more operators that I want to focus on a little bit because that's more advanced right now. Those are divisions and modulus. So why I'm saying and why I want to even cover the registers. That's because you can do really nice things with them on the FANUC. And guys, keep in mind that probably this is going to be the most powerful tool for creating some data, saving some data, making some calculations on the FANUC robot, because we don't have so many options like in ABB or in KUKA. So registers are going to be your to-go if you want to calculate something, if you want to make some changes, adjust positions, and so on and so on and so on, while the robot is running without using the PLC. Of course, you can use KAREL programs. You can create the KAREL programs that will do much more complicated stuff, probably faster than a register. But then again, that's the next level of programming, adding the KAREL programs into the equation. Okay, so the most important things, guys, you need to remember about the registers is that you can access them globally. That means a register can be accessed in all of the programs, it can be accessed in the background logic, it can be overwritten by group inputs, group outputs, depending what you will do with them. For example, if you use them in a background logic, then the value in a register can be overwritten every time, I don't know, you get some input on group input, right? And why I say that they are very powerful? Because if they are used wisely, you can really make very cool things with it if you don't have the knowledge or the access to KAREL programs. So I'm going to show you an advanced example of using position registers, data registers that me and my friend work on during my studies when I was making my engineering thesis. So we had a station with two robots, a CNC and a belt conveyor, and I think two magazines, and we were making a program that one of the robots was the head of the family, and basically that robot was telling the other things what to do. So like to start the CNC, open the door, transfer the belt, and so on and so on, and start the other robot, and so on and so on. We didn't have a PLC, so we needed to find a way around for some things. And that's where the registers came handy. So we came into an issue where we needed to set the speed to the belt that was transferring our items from one robot to the other. And the issue was there was no PLC, but the conveyor, actually the self drive, was reading the data using a byte swap. What is a byte swap? So you have 8 bits here, 8 bits here, and they are swapped. So basically when you go from 1 to 16, because we are using a word, robot is going to send them from 1 to 16, but the self-drive was expecting them to be like this. So that means from 16 to 9 and 1 to 8. If I remember correctly, I will show it on the exercises. So, well, how can we do it? So you will say maybe, okay, you can divide it into group 1 and group 2. So that one is going to have 8 bits, that one has 8 bits, and then you send it. it won't work like this because it needs to get a full word. You need to send 16 bits in a proper order. Well, and that was a challenge for us that we needed to go through. And how we did it, we came up with the idea of using the registers and making a byte swap with the registers. How did we do it? The thing that I told you earlier, using the modulus and divisions. And I'm going to show you exactly, I'm going to show you the program that I did. Well, not me, but together with my friend. I'm going to describe how it works during the exercise, so you have a very advanced program that will work with the registers, and also that's a way how to do a byte swap without using the PLC, so it might come handy for you. Let me talk a little bit more about the issue we had. So basically what we end up doing is we were having a value that was an integer, and we were decoding it into the byte swapped word. How we did it? Registers. So we took that word, we took that value and we changed it into bits. So the same way as Robotics is doing it, we were having a value, and then you guys, you know, you have the 2 to the power of 0, 2 to the power of 1, and so on until 2 to the power of the 15, and that's your whole word. And right now, what we did, using the registers, we were able to switch the number into the word. Okay, that was the first step. The second step was we needed to take that word and byte swap it, so the self drive was able to read it. So that was the second thing we did again with the registers. So we had the value of the speed that we wanted to send, we transferred it into the bits, then we byte swap it, and then we send it to group output, and then send it to the self drive. It was really cool. It took us some time to figure it out because by then we were just, you know, a little bit of just few months of experience with robotics. It was a really cool project. I really liked it. We were very happy when we figured it out. So I want to share it with you guys. So again, without further ado, let's get to the exercise. Let's see how it was done. Okay guys, welcome to the exercises. So let's talk a little bit about the registers. First of all, let's go and get inside the program that I created, which is called registers, and let's talk about them. Let's see the examples, and so you know what's going on. Okay, in order to use the registers, you gotta do insert, register, and here you have all of the statements that you can use with the register. So first of all, you can make a register equal to something. Then you can make all of those mathematic operations on the registers and use a mixed logic on a register. So let's use the first statement, which is equals. So what you can say is you can say register, use a number. I'm going to use number 210 is equal to, and you can use all of those statements. So you can assign other register to it. You can assign a constant value, which is you can just put a fixed number to it. You can assign it to DO, DI, robot inputs and outputs. So that's going to be kind of only true or false. So whenever the output is on, it's going to equal to 1. Whenever output is 0, it's going to equal to 0. Group outputs and group inputs, those can actually carry an integer. And then everything else in here. So let's do a few examples. So what you can do first is we can make sure that our register 210, how do we access the registers? Take a look at my latest video. So we're going to say that register 210 is equal to 10, and now you would just want to copy the register 210, the value from register the value from register 211 to 210. So right now you can see in 210 we have value of 10. In 2011 we have a value of 0. Right now when we execute the code, we copied the value from here to here. Just so you know, so you guys can see it. We're going to copy the value from 211 to 210. There you go. So that's equal. You can also do that as a indirect statement that I talk about on my latest video. So like I said before, check it out before. so you know what's going on. Okay, we can use a constant value, so we can just assign a number to it. So we can say that register 210 is going to be equal to 23. So when you go through that logic, the value is going to be stored in the register. The next thing is the DO or DI. So when you use a DO, let's say, I don't know, let's use number 50, which is actually right now on. When you're going to execute that line, we're going to see number 1 in register 210 because the output is on. If we're going to switch off that output and we're going to execute the logic, you're going to see that the value is going to change to 0. So you can use the register also to save the value of an input or an output. The fun part, which I probably you would most see, is using the group inputs or outputs. So you can say that the register is equal to group input, let's say 1, group output 1, I'm sorry. So right now, let's do 3 windows, that will be the best. So right now, if you go to your group outputs, right now on group output 1, we have value of 3. So when we're going to execute that logic in the register 210, I'm sorry, you're going to get the value from that output. So when we execute it, boom, we got number 3 because we just copied the value from group output. The same, guys, for group input. So if we have a group input, you can also store those in the registers. Okay, what else can we do? Then the other things I'm not going to go through it, they work basically pretty much the same. Let's go to the mathematic operations, which are going to be much more fun. So let's get rid of that line and let's check out the next instruction that we have. So that's the plus instruction. So what does it mean is we can make mathematic operations. So let's say we can use the register 210. The most common one is kind of like I plus, like you have in C++ or C#, where you make a loop and you want to count how many times that loop went through. In FANUC, you're going to use register for that. You can also use AND for as well. So what you're going to do is you're going to use register. So we're going to use register 210 plus a constant value, and that's going to be 1. And right now, if you're going to make a for example, jump label, that we're going to go through later on, every time you run through this function, whatever value you had in register 210, you're going to add 1 to it. So right now we have 3. When we execute that logic, we're going to have 4. And next time you're going to run this program, you're going to get 5. Next time you run this program, you're going to get 6. So you can use it for, I don't know, maybe you want to count how many times you run a function or so. That's where you can use the mathematic operations using the plus. Okay, what else do we have? Let's delete this one. Then we have the minus. How does the minus work? Oh guys, of course, that's just a, we can subtract. So basically we can do the subtract. So now we can count down. So if you want to run that program, I don't know, 5 times, for example, one way of doing it, you can use a register, and after you run 5 times, the value is going to reset to 0, and you can execute other function. Okay, what's next? Next is multiply, which, guys, does just a simple math. So we can do something like this. And right now, the only thing is going to happen, you're going to multiply the value that you have in that register by 2 every time you execute that function. So those are, guys, pretty straightforward functions for the registers where you're doing some mathematical operations. In FANUC, that's the way how we handle mathematic operations, unless you want to use, of course, let's say KAREL. Then of course you can make a little bit more complicated functions, but that's the basic that you're going to get in here. With all of the basic options, you have the plus, minus, then multiply, divided by, divisions, and modulus. So if you're going to divide by a number, you're going to get the value in here. Guys, as I said, register can handle both integers and real numbers. So you can get both in there. Okay, that was the easy part. Now let's see what is those three last options. So that one is a division. So guys, how does the division work? So you're going to, so it's going to say how many times does this value fits in here. So basically this value multiplied by how many times, it's going to get you as close as possible to this. So if we run this code, let's use 15 maybe, and 3. So if we run this code, we should get number 5 in register 210. Why? Because 5 multiplied by 3 is going to give us 15. But what's going to happen if we're going to put a different value in here? Let's say number 4. So if you run through that code, the value we're going to get is number 3. Why? Because 3 multiplied by 4 gives us 12. And that's the closest value you can get. That's the closest value you can get before getting to 15. Because if we add one more 3, then we're going to get 16, and that's over 15. So that's how the division works. Let me show you one more example. So right now we're going to get a number 5, because 5 multiplied by 2 gives us 10. If we change that value to 3, we are going to get number 3, because 3 multiplied by 3 is giving us 9, and that's the closest value you can get to 10 with this division. All right, why do we use it? In a moment I'm going to show you a program that I did, and it's going to show you nicely how it's done. Okay, so we have that, and what else do we have is the modulus. So this one is going to give us whatever is the rest of that operation. So right now, if we run through this, we should get number 3 in register 210, and in register 211 we should get number 1, if I'm not mistaken. So why? So this one, like I've said, means that number 3 multiplied by 3 gives us 9, and this is the closest value we get to 10. Now in here, the modulus works kind of like steps. So it will give you the value of how much the rest basically of that operation, of the division operation. So because that was a 9, we are missing a 1 in order to get to number 10, correct? So that's why we've got a 1 in here. Because 3 multiplied by 3 plus this value gives you number 10. So basically, this one is going to get you the division. This one is kind of going to give you the rest of the division. Let's do a different example. Let's get a higher number. Let's do 15. And let's do 4. So if we do that, we already ran through this. We're going to get number 3. And in here, we're going to get number 3 as well. Why? Because 3 multiplied by 4 gives us 12, which means 15 minus 12, we need still 3 in here. So when we do this one, you know that we are missing 3 to 15. So basically this function, guys, works like 4 plus 4 plus 4 gives you 12. The next step that you're going to get is too high. Okay, but how many steps can I get to 15? So I can get 3 more steps, because 12 plus 1 is 13, plus 2 is 14, plus 3 is 15. So that's how the division and modulus work. Well, now you're going to ask me, oh, where can I find this useful? Well, guys, I'm going to show you right now. So like I said in the introduction, that's the project that I did with a friend of mine for the studies. The function is a little bit complicated, by then that was the way how we solved the issue, because like I said, we didn't have any PLC. The only thing we had was the registers and 2 robots, so we needed to solve the issue. Okay, so we have the function in here that we created, set speed, and that function is having 2 arguments. So the arguments I'll talk about later, but basically you just pass this value inside the function. And with that, we were sending the speed to our Ceph movie drive. The issue that we had was we needed to use the byte swap, like I've said. So instead of sending 16, 15, going back to 1, we needed to send, I think it was 9, 8, and so on, and then 16, and so on in the bits, like I've shown you during the intro. So let's run this function step by step. So what do we do in here? First of all, we're going to save the arguments, so the 1500 in here and the number 0 in here. So let me clear this up so you'll see how everything works, maybe. And the first one. Okay, let's make sure that you will get all of the values. Alright, so when we run through the beginning, the first thing we'll do, we're passing the arguments, we're passing the second argument. So we have our speed to be set to 1500, the direction of the movement excuse me, is positive. So we have 0 in here, and then here is the logic to make sure that the value that you want to send is not greater than the one that the motor can handle. And here is the logic for the direction, either going left or right. Now, because of the gearbox that we are using, we needed to multiply the value by 5 in order to get the desired speed. So this is just for the mathematic stuff that we needed in order to get the right speed. Again, the stuff for the speed, either going backward or forward. And here is the magic we're going to do. So as you can see, we use both division and modulus in here. And what is going to happen? First, how we did it, we're going to decode the value that we had, so the integer, into binary. So that's like, you know, the your value in the power of 0, and so on, so on, so on, so on. So you're going to have 1 and 0s in here, like you would send it on the regular group output. So we go one by one, and as you can see, every time that we run through the division and the modulus that we can do, we're going to get 1 in there. So because the value was 7500 in here, we use this function, so we got number 1. Whatever is left in here, now we're going to get through the next function. Boom. So we could divide the value by 2048. Now from the value that we have in here, we want to do the modulus. So basically we're kind of going to subtract that value. Bang. Okay, now can we make this value out of this? Yes, we can. So we're going to get the 1 in here. Now let's do the modulus. So we can subtract, because again guys, remember how the modulus function work. This if we can, that one I won't explain because we're not going to get 1 in here because this is greater than this, so we're going to skip this one. Okay, now when we're going to go through that function, we're going to get the lower value. Bang, so I got the 1, and now because we had 256, we have 333 in here. When we do the modulus, we're going to say, okay, this fits in there 1 time, and we're going to subtract whatever is left so we can get the value. So we got the 76, because 76 plus this value is going to give you the 332 that I had there earlier. And we keep on going until number 1. Okay, and now we got it in here. So the value I got in here got decoded into single bits. So if you would put it as a word right now, so I have 16 bits from 0 to 15, and if I do this as a group output, you're going to get 7,500 that I got in here. But the issue was, like I told you, I need to byte swap this part with this part, meaning that the bottom part has to go before this part, or the top part in here. So we needed to create a function now that is going to reverse, as you can see in here, the logic. So in here, because you have all of the bytes, let me just scroll this all the way down so you can see. Okay, so as you can see, before this was our byte number 15, this was bit number 15, bit number 14, and so on, so on, so on, so on. So actually this value was giving us this value, right? The bit number 14 was giving us this value, and so on and so on. So the only thing that happened basically is now, like I said, we took everything that was in here and we put it in here at the front of the program, and whatever was in here we put it at the back. So as you can see right now, when I run through this program, you're going to get the values. All right, and as you can see, definitely when we do the value in the power of 0, in the power of 1, in the power of 2, and so on and so on and so on and so on, those are not the values that you're getting, right? That's because of this function that we did in here. So right now we got our number byte swap. The last thing that it left is just going to transfer those values into one register, which is register 200. So we go through that. So basically we're adding all of the values that we got, and boom. So this is the speed in here that's byte swapped from the value that we had before into the value that the Ceph motor could read. So that's how we did the byte swap in using just the registers. So like I'm saying, guys, the registers are very powerful. I think it's very good to know them, and you can make many interesting things with them, and play with them, use the functions, see how they work, and really you can make like logging functions. I was making loggers to see if my outputs or inputs are turning on when I want, and so on and so on. Okay, that's all from the exercises. Alright guys, I hope you enjoyed the video. I hope you enjoyed the example. If you want more examples like this, don't forget to like, subscribe, Like always, leave your comments down below. I'm always very interested what you want to know. And see you in the next video. Bye bye.